No, that's so okay. Dividing rational expressions, the continuation, right? There's only a couple of pages, which hopefully, running off of a local copy on the desktop, will actually go smoothly. Without the use of a calculator and using the fact that root 2 is approximately equal to 1.4142. We got like 3 more decimals than before. Find the length of the base of a triangle if its area is 100 square centimeters and its height is root 50 centimeters. All right, so I'm just going to draw a little sketch. Throw root 50 in there. This is the base. This is the height. What do we know about triangles in area? 1/2 base height. We know that the area is 100. We know that the base, we don't know, and we know the height is root 50. So basically we want to solve this for b, and apparently root 2 is going to come in here. So we'll multiply both sides by 2. So b will be 200 divided by root 50, but root 50 is 5 root 2, right? Okay. I'm just doing that. Like today, I'm not showing like 6 different steps to get to it. It is what it is, right? It's 5 root 2. And then 5 goes into this, so this will be 40 over root 2, which would then be 40 over 1.4142. Right, that's what somebody else showed as the answer. I mean, I don't know if we're supposed to estimate that or something then. I mean, why would you do this without a calculator in that? But then, why would you also give 5 decimal places? Anyways, done, over, forget it. But it was dividing a radical. So a simplified radical expression has the smallest positive, right? So if there's a negative sign under an odd root, like a cube root, we take that out. So it's the smallest positive radicand possible. A rational denominator, right? So rational, we can't have an irrational, like a root 2, right? Root 2 is irrational, so we can't have a root 2 in the denominator. And a coefficient that is reduced. Okay, so reduced coefficient, positive radicand, smallest positive radicand, and rational denominator, and reduced. So root 150 over 10. So really all we can do with that is say, okay, what's the largest square that goes into 150? 25. How many times? 6. Okay, so this is 5 root 6 over 10. 5 goes into 10 twice. Root 6 over 2. Okay, smallest positive radicand possible, check. Rational denominator, check. Coefficients reduced, check. No coefficient. Well, a half is the coefficient. Root 150 over root 2. So the thing we can do when we're dividing radicals is we can do, so the quotient of 2 radicals is equal to the radical of the quotient, right? So the quotient of 2 square roots is the square root of the quotient. So we just put them together under the root sign and say, all right, so that's equal to 75. Now, if you want, you can go from here directly to here, right? You just say, look, 150 divided by 2 is 75. Sure, this is how it happened, but I'm just going to show it like that. And then root 75, of course, we all know is 5 root 3. Okay, one of us knows, or a couple of us know. Okay, so same deal here, right? Okay, first off, the 2 and the 8. Okay, so that reduces. We can now write a 4 times the root of, the cube root of, negative 96 over 6, which will be 4 times the cube root of negative 16, right? Yeah. 96 divided by 6 is 16. Okay, you got calculators, you can use it. So you could do this, or you can go from here directly to here, right? I mean, I don't mind if you're doing the 2 goes into 8, 4, and 6 goes into 96, 16, so you just get to this line, right? 1 step, 2 step, however. Okay, 4. So what comes out from under the radical sign? Negative 2. So it's 4 times negative 2, the cube root of what's left under the radical sign? 2. So we get negative 8 cube root 2. Smallest positive radicand. Simplified coefficient, rational denominator. Okay, this guy, so we can either do it 2 steps, 98x to the 5th over 2x cubed gives us the root of 49x squared, right? Or we could do that in one step. You could just look at that and say 98 divided by 2 is 49, x to the 5th divided by x cubed is x squared. Here we go, and the answer is 7x. Now, this was the easy stuff, right? The radicands in the denominator, the radicals above, are factors of the radicands in the numerator. Remember, they'll go in, right? If I set this up, this division, right? 150 is divisible by 2, 96 by 6, 98 by 2. What if it's not the case? Then what? How do we simplify those types of radical expressions? Look at words. Okay, so remind me, always run a local copy and we'll avoid. Okay, so this time we can't put the 40 over the 3, right? Oh, we can, but that's not going to do any good. So what we have to do is a process called, why are the first two the same? That's not the process. Are your first two the same as well?
Yep.
No. Okay. So should we do the first one or the second first one? Okay, here, we'll do this. We're going to do rationalize the denominator. That's the process we're going to do. Okay, because we cannot have a radical, right? A square root, cube root, whatever, which is irrational. We can't have an irrational number in the denominator, right? Sometimes we maybe do want it there, but that's special cases. So here's how we do it. We multiply. So if I take root 3 and multiply it by root 3, I'm going to end up with 3. So what do I need? What else do I need there? I can't just. Yeah, I got to multiply the numerator by root 3, right? What's root 3 divided by root 3? What's that work out to? 1. If I multiply something by 1, do I change its value? No, right? It's the same. But I'm going to change its form. Okay, so what do we get up top? The root of 120 over, okay, so let's say 2 times 3, which is 6, right? Now, I might have wanted to say, oh, what is it? Well, we could have simplified the root 40, right? Made it like 2 root 10. But here we are now, so we got to simplify this. What's the largest square that goes into 120? 4 go in? Yep. 16? Nope. I mean, if 4 goes in, I want to try 16. So 16 doesn't. Okay, so it's going to be 2 root 30 over, well, if I make that a 6, then I'm just going to have to remake that a 3. So it's just root 30 over 3. So it might have been better to just do this as 2 root 10 to begin with. So let's go over here. Maybe that's why there's 2 of them. You could do it 2 ways. So now I get 2 root 30 over 2 times 3, which is root 30 over 3. Hey, look at that. So maybe there was a reason why it was there twice. Okay, because you can do it a couple of different ways, right? You can just straight multiply it out and then simplify, or you can simplify first, then multiply. 16x squared over root x. What do I multiply by? Root x over root x. So up top, what do we get? Nope. We get 16x squared root x, right? 16x squared root x. I don't want to put the x squared under the radical, because the whole idea is we're simplifying, right? What's on the bottom? X. What's it become? Okay, so the x takes out 1 of the x squared, right? It becomes 16 x root x. And that's it. Don't go any further. Don't try and move the x under the radical sign, right? Because we want the simplest expression under the radical sign. Cube root 20 over cube root 6. Now we can reduce that, right? Because 2 goes into both. So we could rewrite this as cube root 10 over cube root 3. Okay? Okay, now what are we going to multiply by? Cube root 3. Just cube over cube root 3. Yeah, exactly. Okay, so first step, let's just write it down here. So I'm going to reduce this, cube root 10 over cube root 3. Then I'm going to say, okay, multiply that by cube root 3 over cube root 3. What do I get up top? Cube root 30 over, oh, we got a problem now. Wait a sec. If we do that, we're just going to get the cube root of 3 squared, and that doesn't actually have a cube root, right? Now we're just stuck with cube root 9. All right, so think about it then. What do we actually need under that radical sign? We need a perfect cube, right? So I got the cube root of 3, so I'm going to have to multiply it by 3 squared, right? Because that will give me 3 cubed. All right, luckily we can do this without erasing anything. Well, we're going to have to erase that third, so clear that in line up. You say, oh, this is different, right? So cube root 3 squared, cube root 3 squared, right? So what I need to do is bring this up to a perfect cube. Okay, so what's 3 squared? 9. So what do we get up top? 90. What do we get on the bottom? 3. Okay? Wrap your heads around that. All right, so for square roots, it's kind of easy, right? I just need a perfect square. So I just multiply by whatever there is there. For a cube root, it's, I got to look at it and I say, I need to make a perfect cube. Okay, and I've got a 3, so I have to multiply it by 3 squared. Okay, now 90 is a perfect cube that goes into 90. So what is the perfect cube? 8, that doesn't go into 90. What's next perfect cube? 27, that doesn't go into 90. 64, no. Okay, so that's it. Right, we can't simplify the cube root 90. All right, 16 over 3x squared. What are we going to multiply by? So first, let's split that out into 2 things. Okay, so what do I need to multiply by to make the 3 a cube? 3 squared. What do I need to multiply x squared by? X. Okay, so that's what we're multiplying by, right? So we have to look at the denominator, and we got to say, I need to get a cube out of this, so I'm going to have to multiply it by 3 squared. And I need to get the x cubed, right? I can't have a root x sitting around. And whatever I do to the denominator, I do to the numerator. Oh, and cube root 16, we could actually, that's like 2 cube root 2, right? Okay, so, I don't know. What do you want to do with this? We can, all right, let's do that. So we got cube root, okay, hey, never mind. Okay, 2 cube root 2 times the cube root of 3, 9, let's clean this up. Okay, so times the cube root of 9x over what? What's on the bottom? 3x. Right. Yes, I need a cube root sign on the 9x. And so our final answer is 2 cube root 18x over 3x. Okay? You could check this, right, by putting a value in for x if you wanted to. And then put a value in for x here. I wouldn't do a whole lot of that. Note that all the radicands above are all considered to be monomials. What happens if the denominator is a binomial radical? First, some review. Okay, FOIL it. Go, do it on your own. FOIL, FOIL, FOIL. How many products will you get? 4. How many terms will that collect down to?
3.
Maybe. Maybe. Not always. Actually, you only louder. Remember, when you multiply a root by itself, you know, don't sit there and go, oh, what's the root of 25? Just say it's 5. Okay, I'm going to pause. Okay, so if I use FOIL, what do we get? We get 25 minus 5 root 2 plus 5 root 2 minus 2. Well, these guys cancel out, and 25 minus 2 is 23. Now, what we have here is what's known as what? A difference of squares. This is the factored form of a difference of squares. So to work that out, you square the first term and you subtract the square of the second term, right? So that's what's happening, right? I'm going to square the first term, 1 times 1. The outer and inner are the same terms but with opposite signs, right? Plus root 3 minus, so they're gone. And then I subtract, so it's minus the square of the last term. So it's 1 minus 3, which is negative 2. This guy is 6 minus 5, which is 1, right? So you can shortcut it. You can just go straight to the 1. When I do that, I usually make mistakes. So I try and actually do the sort of 2 steps, right? Square the first term minus square the last term. Okay, so I actually usually write those down. Square the first term minus the square of the last term. If I don't, I tend to mess it up. Now you might be better, so then whatever works for you. Remember what Mr. Prentice said, math is difficult. What do you notice is missing from each of the final answers above? What don't we have anymore? We don't have any radicals, right? Okay. The pairs of binomial radicals above are called, do you remember? Starts with a C. Let's do math hangman. Can you buy a letter? You want to buy a vowel? Okay, I'll give you an O.
Constant.
Nope. Next letter should do it.
Still not sure.
Conjugates.
Oh, yeah, that one.
Yeah, conjugate. I don't know.
Oh, those.
Oh, those. Yeah, isn't that what we do with verbs in Spanish? We conjugate them. All right, there's all kinds of different meanings. Look, it's working. Look, no lines, no nothing. It's amazing. Thank Ms. Cormos for that. She runs it off of her desktop, so I was just opening it off of the network drive. And for some reason, like to me, if I open off the network drive, everything should just happen locally on the machine. But apparently, I don't know if it was going back and forth over the network, which to me makes absolutely 0 sense, so it probably was. Okay, remember, a simplified radical has a rational denominator, or for those of you just arriving, a simplified radical has a rational denominator. In other words, no radical in the denominator. All right, simplify the following. So what do we got to multiply by? 5 minus root 3. Okay, so you multiply by the conjugate. Don't get fancy. When you're multiplying by stuff, it's just the exact same 2 terms, right? Opposite signs. Okay, up top. Well, 11 times we get 55 minus 11 root 3. And on the bottom, we get 25 minus 3. So it's 55 minus 11 root 3 over 22. Does that simplify? Right, they're all divisible by 11. So you just divide out the 11, right? Or factor it out of the top and the bottom and cancel it. Okay, 3 minus root 5 over 1 minus root 3.
Wait, where's the 11?
Or 11.
The 55
Like the 11 up top, so I multiply the other term
Yeah,
by.
but isn't 11 multiplied by 55 is 55?
What?
Multiply the 11 by both.
11 times 5, 11 times root 3. Right? Monomial times binomial. Here. We'll make like. There. Is that better? Here, let's throw an extra here. You have to. Okay, what do we multiply by here? All right, so let's do this, right? Put brackets around everything, right? Anything that's a binomial, put brackets around. It'll make it a little more clear, right? It'll cue you into, oh, right, I gotta multiply. What are we multiplying by? 1 plus root 3. Yeah. Okay, so up top we've got 3 plus 3 root 3 minus root 5 minus root 15. Now this is a case where there are 4 terms. And there are 4 terms, right? That's it. There are 4 terms. They don't collect, right? There's no like terms, right? Because I don't have I don't have a root 5 and a root 5. I just have a root 5 and a root 3. So we get 4 distinct terms. All right, and what do we do on the bottom? 1 minus 3. Okay, so we got 3 plus 3 root 3 minus root 5 minus root 15 over negative 2. Now, it's usually better not to have a negative in the denominator. Okay, so you might write it like that. That's fine. I'm not going to, object too much. Or you take the negative out. So what you can do then is change the sign of everything, right?
How did you go from -3 to -2?
It's 1 minus 3.
Oh.
Like that. With the stroke of a pen.
Well,
Okay, so these guys change. They become positive, so let's lead with the positives. Root 5 plus root 15 minus 3 root 3 all over 2. Okay. Now just be aware, you might see it in either form, right? And it's just get used to the fact that, you're doing multiple choice and you look and it's like, I didn't get one of the answers. Okay. And you did, it's just in a different form. So you need to now look at your answer and say, can I change it so it's in one of these alternate forms? Okay, what do we multiply by? Okay, and let's throw brackets around everything, which are actually parentheses, but clean that up a bit. Okay, equals. So what do we get up top? 6 root 5 plus 8. So all that twigs me is if I get an even number in the denominator, then it's going to reduce, right? Because these are both even. Okay, what do we get on the bottom? Good thing it's not ink, it would be bleeding into the paper. 45, right? So 3 times 3 is 9. Root 5 times root 5 is 5. 9 times 5 is 45. Minus 16. Okay, is it even on the bottom? Nope. So we get 6 root 5 plus 8 over 29. Okay, what do we got? 2 more? 3 more? 3 more. Okay, do it. You can do it. You're ready to solo. Fly on your own. Little bird, leave the nest. I'll give you a head start. Leave this up. If you're watching the video, just fast forward. Scrub through. done? Is that it? So, wait, hey, they're all divisible by 2. Wait, not only 2, but 4. They're all divisible by 4. So what you could do is, so this is what really happens. Okay, this is what really happens. All right, let me just cross these guys off. This is what you're left with, which is just the 6. So you could go from that line to that line, right? I'm just going to divide everything by 4. Okay. What really happens is you're factoring a 4 out of the numerator, you're factoring a 4 out of the denominator, and then you're canceling the 4. Okay. So if that's what's really happening, the effect is just the same as if I just divide everything by 4. Okay. So is that what you got? Word. Do the next one. If it's a monomial denominator, but if you have like 2 root x, you're just going to multiply by root x. You don't need to multiply it by 2 root x. That's why it was crossed off. All right, let's do this one then. Yeah, I know, eh? Okay, throw parentheses around everything. Just to remind you that you either have to use FOIL or distributive law, right? If you have a single term up top, monomial, you're foiling. If you have a binomial up top, then you're... And sorry, if you have a monomial up top, you're using distributive law. Binomial up top, you have to use FOIL. Okay, what do we got? 4 root 10. Okay, so in this case, 4 terms, right? These are 4 different terms. Nothing is going to collect together. Okay. And sometimes we get some big numbers in the bottom, right? I mean, it doesn't seem that much at first, like 4 root 5 times 4 root 5, but that's 16 times 5, right, which is 80. Okay, questions, comments, concerns? Right, so then, yes. Just root 6, isn't it? I'd like to say I did that on purpose, but thank you for pointing out before I hit done and then had to go back in and say, whoops, this should be a root 6. See, easy to mess up, right? Minus root 6. Okay, and then just take one last look, one last look, and just say, root 10, root 6, can I write them as both root, root 15, no, okay? So I can't simplify any of the root 10, root 6, or root 15. They don't collect. I don't have even numbers in front of everything or odd numbers. There's no 11 multiples or whatever. So this is it. Yes? Make sure. Okay? Everybody agree? 100%? Going up? Got your stamp of approval?